So, let's talk about something truly remarkable. It's called biochar, and it has this incredible potential to heal our planet, literally from the ground up. This stuff could totally change how we think about fighting pollution. Right now, our soil is in trouble. It's literally crying for help. The very ground beneath our feet, the foundation of our ecosystems, is just soaked with pollutants from years of industrial activity. It's this quiet crisis happening all around us, and the search for a fix is taking us down some really interesting paths. So, where do you even start to look for an answer? You'd think we'd need some futuristic, high-tech gadget, right? But what if the solution has been buried all along? I'm talking about an ancient science, something we're just now rediscovering to tackle our most modern problems. Okay, so first, let's get a handle on the problem. We've inherited this toxic legacy. We're dealing with polluted landscapes where toxins are threatening the entire food chain. So how does biochar actually fight back against all this? Well, it all starts with a first step that is just brilliantly simple. It acts like a trap. It just locks away those harmful toxins the second it comes into contact with them. Okay, so what is biochar? You can think of it as a very special kind of charcoal, but the secret sauce is its structure. It's incredibly porous and has a massive surface area. Imagine a sponge, but on a microscopic level and way, way more powerful. It's like nature's perfect super sponge, built to just soak up all those contaminants. And this trapping process, it's like a three-part strategy. First up is adsorption. That's just a way of saying toxins physically stick to biochar's huge surface, kind of like lint on a sweater. Then you've got ion exchange. This is super cool. It actually swaps out bad guys like lead or cadmium ions for good guys like calcium. And for anything left over, there's precipitation. This part basically turns the heavy metals into solid, stable little minerals, so they literally can't go anywhere. And what's the end result of all this? This is the crucial part. The toxins aren't just shuffled around. They are completely locked down, immobilized inside the biochar structure. They're basically put in jail, making them totally harmless and unavailable to plants, animals, and our water. But wait, because trapping the bad guys is only part one of the story. That same porous structure that makes it a great trap also makes it, well, a five-star hotel for nature's own little cleanup crew. All those beneficial microbes. Just look at the difference here. In regular old bare soil, these helpful microbes are out in the open struggling to survive. But you add biochar, whoa, it's a total game changer. Suddenly they have a safe haven, a protected and stable home. The biochar holds onto water and nutrients, creating this perfect little world for these tiny organisms to just flourish. So we're not just giving them a basic hotel room. We're giving them the presidential suite. The biochar provides safety from predators and a constant buffet of food and water. And we can even get strategic with it. There's a process called bioaugmentation, where we can preload the biochar with specific pollutant-eating bacteria. It's like sending in a special ops team that's trained for one specific mission. Okay, so the toxins are trapped, and the microbes have checked into their luxury hotel. Now, this is where the real magic happens. The transformation begins. It's time for nature's cleanup crew to get to work. Feeling safe and well-fed, these empowered microbes start producing these powerful enzymes. Think of them like tiny molecular scissors. They get to work snipping apart those complex, toxic molecules that the biochar has already trapped for them. And what you see here is a complete transformation. You start with these complex pollutants. Then, the microbes go to work with biodegradation. And the biochar itself plays a role here too. It acts like a conductor, helping to speed up the chemical reactions. And the after? Simple, harmless stuff like water and CO2. The toxins are literally taken apart, piece by piece, at the molecular level. All right, so the immediate danger is gone, the toxins have been dealt with, but what happens next? What about the long haul? See, this isn't some quick, temporary fix. The final part of this story is about the incredible, long-lasting legacy that biochar leaves in the soil. And I want you to really let this number sink in. We're talking about hundreds of years. That is not a typo. Biochar stays put, stable in the soil, for centuries, sometimes even millennia. So this isn't just a cleanup job. It's a long-term investment in the health of the land, one that improves the soil and locks away carbon for generations. And all that time, it's still working. It permanently improves the soil's structure, giving roots more room to breathe. It holds on to water, acting like a little reservoir during dry spells. So what does this all add up to? Well, it creates the perfect foundation for native plants to come back, which in turn drives the recovery of the entire ecosystem. So when you piece it all together, you've got the trap, the hotel for microbes, the complete transformation of toxins, and then this incredible centuries-long legacy. You really see the whole picture. Biochar isn't just a single tool. It's an entire sustainable system for bringing our environment back to life. Think about it, from locking up toxins on day one to rebuilding a whole ecosystem over centuries. The potential here is just immense, which really leaves us with a big question to chew on, doesn't it? As we face bigger and bigger environmental challenges, could this ancient, rediscovered science actually be one of the most important keys we have to healing our planet?